All right, hello, Avalie. This is section 9.2. We've got this for homework right here. And this is the Pythagorean theorem. Most of this is straightforward. You guys know the Pythagorean theorem. You've done this before, but there are a few new things that are a little bit different. And we'll go through this section kind of fast. So here we go. We are up at, let's go through the first example, and then we'll talk about these Pythagorean triples real quick here. So example 1, x, 7, and 17. This is a right triangle. This only works, Pythagorean theorem only works for right triangles, yeah? Okay, first thing, which side is side C?
X.
Yes. It gets a little bit confusing, especially when they write the triangle in this way, because it, like, people are used to looking for the slanted side. So I have a lot of people that will look and say, C is 17. That is not true. Look for the 90-degree angle, and it's the side that's like across from him. That's your side C. Got it? Okay, which one is A?
17 or 7.
Doesn't matter. A and B can be switched around, but C has to be side C. Got it? All right, let's do this. A squared is 17 squared. B squared is 7 squared. C squared is x squared. 17 squared is 289 plus 49 equals x squared. This is 338, and the square root of that, which is something. I don't know.
3 squared is 2.
Give it to me as a decimal. You guys can put them in as decimals. I'll let you. The square root of 338. We're in example 1. I have a calculator. Square root of 338.
18.4.
18.4. There you go. Very good. Okay, now, those three are the correct sides that work with the Pythagorean theorem, but there are some times where you have your three sides come out where none of them are decimals. Here I had one of them as a decimal, 18.4. You have perfect Pythagorean triples is what they're called, where none of them come out as decimals, right? 3, 4, 5. 3 squared plus 4 squared equals 5 squared. That is a legit thing. 3, 4, 5. Memorize him. 3, 4, 5. Some of you guys do already. Memorize this one. 5, 12, 13. 5 squared plus 12 squared comes out to be 13 squared. That's the way that it works. Okay? Other ones are 8, 15, 17, 7, 24, 25. You can write this one down as a 9, 40, 41. He also works. And there's more than that, but they're like in the hundreds, like 103, 127, and 154. I don't know. So these are the ones that are under 100 that are perfect Pythagorean triples. Now, why memorize them? I would memorize, so we have a shortcut. I would memorize these first two. 3, 4, 5, 5, 12, 13. Okay? Now, this makes your life easier because then you can solve them faster and you don't have to do the full Pythagorean theorem. Okay? Keep in mind, a 3, 4, 5, a 6, 8, 10 is also a 3, 4, 5. It's just multiplied by 2. Got it? A 9, 12, 15 is just multiplied by 3. So a 9, 12, 15 is also a 3, 4, 5 triangle, right? A 10, 24, 26 is a 5, 12, 13 triangle. Got it? Here's how it makes it easier for you to solve. Shh. Are you listening? Okay. Here's how it makes it easier to solve. Example 12. 14 and 50. Not example 12. Example 2. 14 and 50. Check those out. 14 and 50 will reduce. Yeah?
7 and 25.
If I divide by 2, 14 becomes 7. If I divide by 2 here, 50 becomes 25. Yeah? Okay, I have a triple that's 7 and something and 25. 24. Okay? But this guy won't be 24. If I divide it by 2, I have to multiply 24 by 2, and that gives me 48. So this side is 48. That was much faster than doing the entire Pythagorean theorem. Yeah? Let's go down to this one. 20 and 48. I can divide both of those by how much? 20 and 48. What can you divide by? 4. 48 divided by 4 is 12. Okay? 20 divided by 4 is 5. 5, 12, 13. But I have to take this guy and I have to multiply him by 4, which is 52. You're right.
Yeah,
You're right. You're right.
I thought you were multiplying.
Nope, you got to multiply by 4 to get him back up to the actual scale factor. Does that make sense? Mm-hmm. Knowing those makes it go really fast, okay? Instead of having to do a squared, b squared, c squared the whole time, you can just do that shortcut, Okay, now again, sometimes it might come out to be where you have to actually get a decimal, and that's fine. But if you have ones that are really nice, you can use those triples to find them. Good? Okay, let's do example 3. This is one where we can't do a triple, I don't think. I don't think it comes out nicely. So which side is side C? The one we don't know. So which one is A?
The bottom.
Doesn't matter. Bottom one, sure. Okay, B is here. So we've got 775 squared plus 450 squared equals C squared. You should be able to type that whole thing into your calculator. Yeah? 775 squared plus 450 squared. You get a big old fat number. It's like a
3,125.
Okay? And then to take the square root of him. Do you guys all know how to, in your calculator, take the square root and write the answer in there rather than having to retype it? Do you guys know how to do that to save you time? I'm going to show you right now. Okay? If you have a calculator and you had that number, and I'm going to take the square root of him, rather than retyping that number in there, you see this A and S, you go second this guy, and it will take the previous answer and take the square root of it for you. So you don't have to retype anything. It's faster. Anybody else need just shown where your A and S button is?
Difference between the pre-ANS and just ANS. Because I just pushed ANS and it
The what?
That's what you want.
Well, what's the difference between the
what?
push?
I think pre-ANS, it will take like the answer that's like 2 before. You get to choose which number to take before. So like if you typed it 2 lines before that, you can go pre-ANS and then you can go up and choose what your number is to insert in there. I think. So. Good? Yes? Okay. What do we get there, by the way?
896.
896.2 meters. That's what he is. 892.6 or 896.2. Round to 1 decimal place if it doesn't come out as a nice number. Good? Yes? Okay, next thing. This is like the last concept. Okay? This is the converse or like the opposite of the Pythagorean theorem. Not opposite. The Pythagorean theorem backwards. Okay? Alright, let's do 3 examples. I'm going to list them here. Ready? I'll illustrate this for you. Example. Put these off to the side. Here are your 3 examples. Example, example, example. Okay? Let's say you have 15, 36, 39. Next example. Let's say you have 5 and 8 and 12. Then let's say you have 7, 10, and 11. Okay, those are your 3. All right, we are doing what's called the converse of the Pythagorean theorem, which is like using it backwards. Here I know all 3 sides. I'm not trying to solve for a side. I have all 3 sides. I want to know if it's a right triangle or not. Yeah, is this a right triangle or not? So your side C is not always the one that they list last. It's the biggest one. So in this case, my side C is the one that they list last, but be careful of that because sometimes they won't list them in the correct order. Okay, so in this case, 15 squared plus 36 squared should be equal to 39 squared if it's a right triangle. Yeah? 15 squared is 225. 36 squared is I don't know.
Or we can divide it all by 3 and it's 5, 12, 13.
You're true, yes. Yes, we'll get to that. Okay, what's 36 squared?
1296.
1296. Okay, and what's 39 squared? Something 51.
Is 1521.
1521. Okay, if you add these 2 together, do you get 1521?
Yes.
Yes. So what's that mean?
39.
That's a
Right triangle. Okay? He is, in fact, a right triangle with those guys. Now, Remington said, you too, knock it off.
Knock it off. Keep your
Okay.
hands to yourself.
Just quit touching each other.
Yeah.
All right. Remington said, you could instead, these 3 numbers will all reduce by 3. If you divide by 3, you get 5. If you divide by 3, you get 12. If you divide by 3, you get 13. And we know he's a perfect right triangle, so he's good. Make sense? Instead of running through the check. Okay? But he is, in fact, a right triangle. Now, these next 2, I'm just going to warn you, are not going to come out to be a right triangle. But we can tell whether it's an obtuse triangle or an acute triangle. So you're going to have to do that on some of these problems, okay? What does obtuse mean, by the way?
Greater than
Yeah, that means I'm going to have a side that's really big, and I'm going to have an angle up top here that's greater than 90, right? Acute means all three sides are going to be about the same, right? Ish, makes sense? So obtuse, acute means all of the angles are going to be less than 90, yeah? But obtuse means I have one angle that's really big, okay? So here's my example. 5 squared plus 8 squared, and then we've got 12 squared, okay? I want to see if they're equal. This one's not going to be equal, but let's see what's happened. So 5 squared is 25, 8 squared is 64, 12 squared is 144, okay? If I add these two together, 25 and 64 is 89, okay? All right, are you ready for this? Are you listening? This side right here was my biggest side, right? That was my side C. And he himself, just by himself, is bigger than the other two sides added together. So what I have going on here is I have a really, really, really big side. And when you have a really, really, really big side, you're going to have a really, really, really big opening, right? Which means this is going to be an obtuse triangle. Does that make sense? Your biggest side is bigger than the other two. So he's going to be an obtuse triangle. Okay, versus this one. 7 squared plus 10 squared is in what relationship to 11 squared? Let's see. 7 squared is 49. 10 squared is 100. 11 squared is 121. 49 plus 100 is 149 and 121. Okay, this guy right here, 121, this was my biggest side. But in relationship to the other two sides, he's fairly small, right? Even the biggest side is smaller than the other two added together, right? So this means that you have an acute triangle where your biggest side is still kind of comparable to the other two sides, and he's acute. Does that make sense? Okay, so if your A and B is bigger than your C, he's going to be acute. If your A and B is smaller than your C, he's going to be obtuse. Make sense? Okay, that is all you have. I'm going to skip example 4. Good? There you go. 2 through 14, 20 and 24. Or 20 and 22, I mean. That's the homework. Okay? Good? Questions? All right, that's it.